Hello, Algebra 2 students. We're getting ready to move on to talk about inverse relations and functions, and we'll do that over 2 days, and I'm going to try to weave in a couple of answers to the questions that you've been asking as we go through this. And I know that I've been looking at the questions that you have, and I will get to them and get them answered here hopefully pretty directly. So let's just move on and do this right now. Okay, so first thing we need to do is to remember a relation is just a set of ordered pairs. Sometimes it can be given as a chart form or a set of ordered pairs just as they are, or it can be given as an equation. In the case of it being a function or some kind of other relationship or relation. We want to talk today about the idea of an inverse. Inverse we think about almost like the word of reverse, and so what we're going to do is to find the inverse is you really just need to switch the x and y values. So in other words, 2, 5 becomes 5, 2. 3, negative 4 becomes negative 4, 3. Try to anticipate the next answers. This should be 3, negative 2, and 2, 1, and 4, 0. So pretty easy if you have a list of ordered pairs to find the inverse, if you make yourself study a little bit so that you remember what that means. We do want to take a look at the graph because the graph of inverse relations comes out to be a pretty interesting thing. So what I've done is on the next picture is I've graphed these points in black and these points in red so that they can pop out for you, but I would suggest that you stop the video and make your own graph so you can kind of see this happening. So here are all of these points, and then when you graph these ordered pairs, you get these points. And what you might notice is that you've got an interesting thing happening here, that this group of points looks like this group of points, but as if it was flipped across a mirror. Okay, so we do say that there is some symmetry involved, but the symmetry is not on the x or the y-axis, but the symmetry is along the line of x equals 1, or x equals y. So x equals y here makes our line of symmetry, where if you folded your graph along these, you see that each one, point for point, has its own reflection, and we call that an inverse. That will work for all of your inverse relations. Some inverse relations come out to be functions, and some don't come out to be functions, and we'll talk about that just a little bit. Okay, and if you wanted to, you could go back and pick your own set of ordered pairs and write the inverse and then graph them, and you'll see that you do get an exact duplicate on the other side. All right, so if your relation is given as an equation, okay, if your relation is given as an equation instead of a list of ordered pairs, we have a slightly different process. You can't point by point go and just switch the numbers, but what you can do is you can switch the variables. Okay, now I also want to get into the topic of functionality here. So this particular equation does generate a function. And if you remember, for it to be a function, it has to pass the vertical line test. You might remember that this is a parabola, shaped generally like this, so that for every x value there's exactly one y value. So if you tried to draw vertical lines in, it would pass. So we're starting with this function, and in order to find the inverse, we switch the x and y. Just like with the list of ordered pairs, you had to switch the x and y, we need to switch the x and y here. So your y becomes an x, your x becomes a y, but in order to graph it, you need to solve for y. So we'll do our little bit of algebra. This part's not going to be too difficult, but the only thing is that when you use the square root to get rid of this square, remember that this could be the positive or the negative version. So you have two different answers for that. You have the plus version and the minus version. Okay, so because we don't know if this was a positive 8 or a negative 8, you wouldn't know if this, if the square root was positive or negative. I said 8 is just an example here. Okay, so our inverse function looks like this. Okay, so we've got the plus or the minus version of this. So I want to look at it in terms of graphing. You might remember our general pattern for a parabola. And if we need to think it through point by point, we can do that. When x equals 0, y equals -1. When x equals 1, 1 squared minus 1 is 0. Same with -1. When we have 2, we get 3 in this case. 2 squared, 4 minus 1 is 3. And then it's reflection over here. Now the interesting thing, remember our graph reflects around x equals y. So it reflects around this diagonal line that goes up the corner. So each point will have its counterpart on the other side of that. So that when we think it through, each one has its reflection. That's one of the ways that you can think about it. Here's a reflection, here's a reflection. Finding those reflected points might be a little difficult, but what you can do is you can plug in points to find the ordered pairs, and you'll find that there are 2. So in order for it to be a reflection here, you do have the parabola turned on its side. Now the thing with a parabola turned on its side, this is not a function. It fails the vertical line test. So for example, at 3, because plus or minus the square root of 3 plus 1, that gives you 2, and it also gives you -2. This is not a function. Okay. However, our parabola is a function. It does pass the vertical line test. So sometimes the inverse of a function or of a relation can turn out to be a function or not a function. You have to evaluate on as far as whether it's a function or not. Okay, so here's our graph. Here is our axis of symmetry. Each one of these points has its own reflection for the inverse. I just have a little bit more. We're almost done for the day, believe it or not. Kind of a short lesson, and then you'll do your practice. Make sure you're doing it all. Make sure you're filling out the online forms by clicking through and just showing me that you came and you listened to the whole thing. Okay, so finding the inverse of y equals 2x plus 8. I want you to just, stop for a minute, and I want you to actually plug in and do that work. I'm going to go ahead and do it now. You've paused to do it, but I know you're coming back, so welcome back. You are going to switch your x and y, so you have x equals 2y plus 8. You want to solve for y, so I'll take away 8 from both sides. X minus 8 equals 2y. And then I'm going to divide by 2. And when I divide by 2, I've got 1/2 x minus 4. So here is finding our inverse. You'd solve for y. If you were going to graph it, mx plus b form is the easiest way to have it in here. So you do want to split this into the 2 different things that were divided by 2. And what we have here, there's our inverse that we just found. Just to remind you, there's where it came from. 1/2 x minus 4. We want to think about its graph, and we want to think about if the relation's a function and if the inverse is a function. Oh, there we go. There's that work again. So when we do the graph, here's our original one. Y equals 2x plus 8. just as a quick little review for you, y equals mx plus b, here's b. It's up 2 over 1, but that pattern goes up into a strange place, so you can go down to left 1 as well, because negative over negative also gives you positive. It's a positive slope, meaning going up to the right. This one also a positive slope going up to the right, starting at negative 4, up 1 over 2, up 1 over 2. This green line is not actually part of the graph at all. Okay, it's just our axis of symmetry that I drew in so that you can once again see that the inverse always has to look exactly like its counterpart but flipped over the line. Okay, in this case the relation is a function. Each along the vertical line it's only going to hit one spot, and the inverse is also a function. Doesn't curve around on itself or anything like that. So that brings us to the end of our inverse relations and functions introduction today. And I hope that you're holding in there pretty good there. And I'm praying for you and your families that everybody is safe and healthy, and that when you have those down days that God encourages you and strengthens you. So I want you to all have a good day. Make sure that you're continuing to stay healthy and encouraging the people around you. Have a really good and blessed day.